Hello, everybody. My name's Caleb, and on today's episode, we're going to talk about relational modeling in .NET using Entity Framework 4. The first thing I do when I'm creating models is I create a base model. The base model has fields that will appear in every single model that I create. So you can see I have a created at field, and then I have some Fluent API syntax in order to automatically assign a timestamp upon creation. I also create a base ID model that extends from base model. So a base ID model, that's what most of my models are going to use. In the base ID model, I set the key. I'm using a GUID key here, which by default in an Entity framework, I'm using the Postgres driver here. By default, that's going to get created client side, and it's going to be assigned a GUID v7 starting with version 9. So GUID v7 is a sequential GUID. It's got a timestamp portion that that allows for that GUID to be created in order. So the GUIDs are going to be, they'll still have a random component, but in general, they'll be created in order because there is a timestamp component of the GUID, and then there's a random component of the GUID. So I think that is a great way to assign an ID. I prefer it over the auto incrementing IDs, so like integer auto incrementing IDs, because it can be assigned on the client. You can actually create your model, and before you hit save changes, once you add it to the DB context, you're going to see that that ID is assigned, and then you could potentially reference it from other areas without making a round trip to the database first. So getting into one of our actual models that has some business logic in it, let's look at vehicle make model. So I've got a database here that's got vehicle makes, models, generations, and parts for those vehicles. You can see vehicle make model, again, extends from base ID model. And here is where we really get to talking about, what's going to show up in our actual database tables. So this vehicle make model, I like to start by just adding comments above each type of property in my model. The first one's going to be columns. So these are just columns that hold data. You can see I've got a name and a country here. And then next we've got some a navigation property. So these are collection navigation properties. I like to put here kind of the rules just so that I remember, or maybe people who read my code can remember, or even if I'm using an AI assistant, that it can understand what the section of properties in this model are and kind of what the rules around those are. So for navigation properties, I use virtual properties here because Entity Framework has an optional thing you can opt into called change tracking proxies, and those do require your navigation properties to be defined as virtual. So I like to just go ahead and put that in my models here. For collection navigation properties, I like to go ahead and initialize those so that I don't have to deal with any null reference exceptions, and I also skip setters on those as well. So that is pretty much the properties that are on this model. And then you can see here, I like to put all of my Fluent API syntax right into this model. I do it in a static function called onModelCreating. So that allows me to co-locate my Fluent API syntax that relates to this model with this model. Now, I'm not completely against using attributes. So for example, I could use like a max length attribute here. If I wanted this name, for example, to be at most 100 characters, I could put a max length attribute on here. But the reason I like using the Fluent API is there's certain things you can't do via attributes, and there's certain things that you can do more of using Fluent API. For example, Fluent API allows you to do multi-column indexes. So I could do an index here for, created at name and country. I wouldn't really be able to do that using annotations. And since I may need to do it using a Fluent API, I just like to do all of my indexes here with the Fluent API. So More commonly than not, I'm only going to use attributes if it only applies to a single field, such as max length or maybe a not mapped attribute. Taking a look at the vehicle model. So I do like to suffix my models with the word model, and vehicle models also has the word model in it. So that's why you see a duplicate model. Because one is like, okay, this is the vehicle model, and then code wise, it's the model for the vehicle model. The reason I like to suffix my models with the word model is it's very likely that I'm also going to have classes named like vehicle model controller or vehicle model API, vehicle model, view model. So the reason I suffix all of my models with the word model is so that it's easy to like search for these files. So if I open up a file search and I type the word model, I'm gonna see the models all pop up in one area, and it becomes very easy to find what I'm looking for and very easy to reason about what a class does without having to dig through the namespace. It also cuts down on naming conflict, like when you have a controller that imports a model, for example, you don't want both of those things to be called the same thing. You wouldn't want vehicle model in your controller as the name of the class for your controller, and the vehicle model as the name of your model. So that's why I suffix these with the word model. Now, getting into vehicle model, you'll see many of the same things we had in the vehicle make model. There's a couple new things here though. We have a foreign key. For my foreign keys, I like to use private setters. The reason I use private setters is because that's going to pretty much force relationships to get assigned to the navigation property as opposed to getting assigned directly to the foreign key. So you can see the navigation. I have a reference navigation property right below that. For reference navigation properties, again, I'm using virtual just in case I want to use change tracking proxies. My model will already be compliant with what those expect by declaring virtual navigation properties. And then additionally, I declare my reference navigation properties as nullable. So that makes it so when you do eager loading, if you haven't loaded a model or eager loaded a reference, that reference will appear as null, and then you can use null checking to figure out that you have not loaded a reference. So that is a little bit different than how collection navigation properties are initialized. And then you can see down in my OnModelCreating for this model, I do explicitly define a relationship. So I like to define relationships in the model that the foreign key is defined in. So I have a foreign key defined here, and then I fully define the relationship. I put both navigation properties on here, so has one with many routing to the navigation properties, and I also explicitly define the foreign key, and then finally give it an on delete behavior. Now, Entity Framework can auto detect a lot of these relationships. You don't always have to explicitly define relationships for it to work. But the reason I like explicitly defining relationships is it makes it easier to reason about the code, and it makes it easier for people reading my code or maybe an AI assistant reading the code to figure out what exactly these navigation properties are and how they're related. Finally, let's look at the vehicle generation model. It's got one additional extra relational definition in OnModelCreating. So you'll see here that I've got, I have a foreign key, I have has one with many definition there, but I've also got another collection navigation here called parts. And down here you'll see I've actually got a has many with many definition. So that's a many relationship, and it goes through another table. So you can see it goes through vehicle generation part model. Again, vehicle generation part model, I still define each side of this. I have has one with many, has one with many. But when you look at vehicle generation model, the reason I put a has many with many here is just an explicit explicitly explaining what this navigation property does, that it actually is a many relationship and it goes through a table. So that is an example of like a relational hierarchy. We have a couple has one relationships and a has many relationship in there. Moving on to my part model, I'm going to give you an example of how I do a table per hierarchy definition. So parts is a table per hierarchy, or it is all part of one hierarchy rather. Part is an abstract class. I've got some, part name, part description that's common against all of the parts. But here I've got a table per hierarchy section in my Fluent API definitions. So the first thing you'll notice here is that I do explicitly define the discriminators when using table per hierarchy. The reason that I do that is because by default, Entity Framework is going to use the name of the model as the discriminator in the database. So if you ever end up changing your model name, that could cause Entity Framework to lose track of what that model used to be called. So I explicitly say the engine model has a discriminator of engine. That way, if I ever wanted to change my engine model to maybe a gas engine model, maybe I wanted a gas engine model and an electric engine model, well, that way I've got a explicitly defined discriminator here, and I might be able to write a migration to change that discriminator if I wanted to ship an update to that. But Entity Framework's not going to lose track of what that is since I've explicitly defined it here. I'll go change that back so when I run this, it's all going to work properly. The next thing you'll see here is that in my table per hierarchy, I do define my base model on part model here, so configure base on that. But once I get into engine model or transmission model, go to those definitions. I don't actually call configure base on those. The reasons for that is because part model already calls configure base. It's all part of the same table. So I don't need to call that again for each derived type. I just need to add my additional Fluent API syntax for each derived type. Next, let's look at the database context. I like to organize my database context, again, with comments. So I like to put comments of like subdirectories of models. So I've got part here. And as you can see, I only put my kind of root type for my hierarchy here, and that's going to be parts. The reason I only put a DB set for parts is because I like looking at DB sets in my DB context that map to tables. So this will create a parts table. I'll have discriminator in there and access to different types for an engine and a transmission, but there won't be an engines table. There won't be a transmissions table. So I like to get a glimpse of what actual tables I'll be dealing with in my DB context. And I'll just put the parts DB set in there. Now, for vehicle, there were no hierarchies within vehicle, so I defined tables for each of the models that I had in my vehicle subdirectory. Moving on, we've got a configure convention section. Here, I map all enums to strings. The reason I do that is because much of the same reason that I define discriminators. We have enum here. By default, Entity Framework would store enum. I believe it would store it like integer values. So United States would be 0, Germany 1, Japan 2, Korea 3. But if I were ever to come in here and maybe reorder, maybe I wanted to alphabetize the countries in my enum and I reordered things, if I were to leave Entity Framework automatically just storing integers here, next time I load that data, it's going to map to the wrong enum. So that's the reason why I map those to strings. Now, of course, if I change an enum value, so United States of America here, that would cause me to need to make a migration. So just be mindful if you map to strings that you should not change the string without making a migration to migrate any of those enum values over to the new string in the database side. And lastly, we've got the onModelCreating section of our DB context. You can see here, I simply do the same thing where I comment each section or each subdirectory so that I can have some organization to this, especially as your database grows from just a few models to maybe tens or 100 plus models. Commenting is really going to become your friend in keeping you organized. And then I'll call the onModelCreating for each particular model. Again, I do not call the hierarchies because in part model it's handling calling onModelCreating for each of its own hierarchies. And let's go ahead and run an example. I've created some seed data. I've got 3 vehicles in this seed data function. And then I've also got Aspire here, so I can start up my application. API service is running. I've got a seed database endpoint or a seed DB endpoint, and I will call that with curl. That's a post endpoint. And that seeds my database. And then I'm going to open up data grip and just show you what that's inserted into our database. You can see we've got the 5 tables that we modeled here. We've got vehicle makes for 3 vehicles, 2 vehicles I wouldn't mind having, and 1 that I do have. We've got vehicle make, Pontiac GTO, Mercedes AMG 6x6, which is a pretty sweet looking car. And then, of course, the vehicle that I actually have, which is a Honda Odyssey, which I might also add is a pretty sweet looking car. So there is our data. The last thing I would like to show is that by commenting these models, adding these comments to the different sections of the model, we can actually use an AI assistant and simply tell it to look at the structure of our model, and those comments are going to give it good indication of how we like to structure our models and how it should make new models. So like this lends itself super well to using an AI assistant like Claude Code. We'll ask it to add a tire model and tell it a little bit about the fields that we want to add. Now, while that runs, I'd just like to talk about the channel for a minute. Don't Work the Weekend is a channel where you can learn about professional programming skills. So we're doing a series here on Entity Framework. We've got a video on how to scaffold Entity Framework with Aspire out there, and we're going to have future videos on how to query against Entity Framework. So if you would like to get updates on those videos dropping, please hit the subscribe button. And of course, I appreciate your support on the channel. Now we'll take a quick break while Claude works here and then check out what it has created for us. And we're back. Claude has done an excellent job creating this tire model for us. It's pretty much followed the exact same conventions that we used in all of our other derived part models. And you can see it's even created the proper enumerations and referred to them, as well as registered the tire model in our table per hierarchy in the same way that we do the other ones. So I hope you enjoyed this video. You can find all of the code that we use for this video in a link in the description below, and we'll see you next time.